Hi, I'm Caitlin Catoni, and in this video, we're going to talk about rearranging common equations used in chemistry class. This video is appropriate for entry-level chemistry and also general chemistry. So let's talk about rearranging equations. A lot of times there's a discrepancy between what your instructor wants and what you're ready to do, and this is one of those cases. When I was a student, I remember being asked to put in units in my equations, and it blew my mind. I could not wrap my head around doing the algebra and also managing the units. So when your teacher asks you to show work, I'm going to show you how to manage the units more easily. The first thing you're going to do for showing your work is you're going to isolate the variable that you need. Then, once you've done the algebra without plugging in any numbers yet, and you've isolated the variable, then you can go in and you can put in units. After you add your units, you can be sure that your units cancel. That's your double check to make sure you did the algebra correctly. Okay, let's go through our first example. In this example, I have the density equation. Density equals mass over volume. So D is density, M is mass, V is volume. The first thing that I want to point out is that multiplication and division are like partners, and addition and subtraction are like partners. They go together. So in this case, your mass is being divided by volume. Let's pretend that our goal is to isolate the variable m for mass. First, we need to recognize what's happening to the mass. The mass is being divided by volume. So in order to isolate the mass, we need to undo that division. The partner for division is multiplication. And so in order to undo the division, we have to multiply. And so what we'll do is we'll take your volume, multiply both sides by volume in order to get your volume to cancel. Whatever you do on the right-hand side, make sure that you also do it on the other side. So now we have volume times density equals mass. Sometimes you're going to see people just naturally put the variable that we're solving for, which is mass, on the left-hand side without going through this middle step here that I'm circling in black, because their brain's just taking on two steps at once. It's just normal in math class to write the variable that you're solving for on the left-hand side. So we can then plug in our numbers with the units and solve the problem. So if you wanted to, I'll show you how the units cancel here. So remember, we're solving for mass. I'm not even going to put in the number. I'm just going to put in some sample units. So if we had a unit of milliliters for volume, we would take our milliliters and put that in. We would multiply this by the unit for density, which is typically grams divided by milliliters. And so now we recognize that our milliliters here is in the numerator, and here it's in the denominator. So our milliliters is in the top in one term and in the bottom in the other term, which means that they cancel. And so now we're left with just the unit of grams. So we've shown our equation, we've done our work, and we've put in our units. And instead of putting in our units at the beginning and then having to manage tracking those units through the algebra, now we can just put them in at the end and saves us some headache. Let's look at another example. So this example is the ideal gas law. Depending upon when you're watching this video, you might not be to the ideal gas law yet, and that's fine, because this usually ends up about halfway through the semester, maybe a little bit more, depending upon the order that your teacher is using. So in the ideal gas law, we have pressure times volume equals moles times a constant times T. Let's pretend that we're solving for moles, which is N. So we want to get n alone. In order to get n alone, we have to look at what's happening to n right now. N is being multiplied by r and by t. And so in order to get n alone, we need to do the opposite of multiplication, which is division. And so I'm going to divide both sides by the two variables that I don't want. I don't want the r and the t to be next to the n because I'm trying to isolate the n. So I'm going to do this to both sides because that's what I'm supposed to do in algebra. What ends up happening is when you get r divided by r, those cancel. T divided by t, that cancels too. So now we have pressure times volume divided by r and temperature, and that equals n. Again, you might see your teacher just go ahead and flip this so that your variable that you're solving for is on the left-hand side. This is a great place for you to do your algebra first before you plug into your units. If you've gotten to the ideal gas law yet in class, you know that the units are very cumbersome and that they take a lot of work, especially R, because R has a huge amount of units in it. So that can probably be its own video. Let me know in the comments below if you would like me to make one of those. For now, let's go to a more common earlier in the semester issue and address that one. So in this problem, we're relating temperature in Fahrenheit with temperature in Celsius. So there's two different ways to write this equation. The first one I've written here, I'm going to write the other way above, where temperature in Fahrenheit is equal to 9/5 temperature in Celsius plus 32. If you take 9 divided by 5 and you put that in your calculator, you get 1.8. So these equations are actually the same. A lot of times you'll see people use the 1.8 instead of the 9/5 because it's easier to manage. If you feel more comfortable with the 1.8, go ahead and use it. Let's focus on the 1.8 version of the equation because it is easier to manage. So I want to isolate temperature in Celsius in this equation. I think that the easiest way to go about this is to first move the 32 to the other side. How are we going to do that? We subtract 32 from both sides. So remember we said earlier that addition and subtraction are partnered with one another. Here you're showing an addition of plus 32. And in order to isolate the TC, we need to get rid of the plus 32. That means doing the opposite of it. So we're going to subtract 32 from both sides. When we do that, we cancel out the 32 on the right-hand side, and we get TF minus 32 on the left-hand side. This is equivalent to 1.8 TC. Remember, our goal is to isolate or to get TC alone. So in order to do that, now we have 1.8 multiplied by TC. The opposite of multiplication is division. So we need to divide both sides by 1.8. So let's divide those. 1.8 divided by 1.8 cancels. So now we have temperature in Fahrenheit minus 32 divided by 1.8. I like to put the temperature in Fahrenheit minus 32 in parentheses because that communicates to my students that you need to make sure that you solve that portion first before you carry out the division. And this is equal to the temperature in Celsius. Like all of our other examples, if you see the temperature in Celsius on the left-hand side and the rest of it is flipped on the right, like I'm going to draw right now, don't worry about it. It's the same thing. It's just convention in math class to put the variable that you're solving for on the left-hand side. Thank you so much for watching. I hope that you found this video helpful, and if you did, give it a thumbs up. You can also subscribe and leave me a comment below telling me what other videos you'd like to see.